You plug a cable into a switch. The link light comes on green. Speed shows 100 megabits per second. Duplex shows full. Everything looks perfect. But when you transfer a file, it crawls along at a fraction of the expected speed. You check the interface again. Still green. Still full duplex. Still 100 megabits per second. Welcome to the world of interface configuration, where things can look right, but still be wrong. Every network device has interfaces. On routers, they are disabled by default. You need to issue no shutdown to bring them up. On switches, they are enabled by default. Plug and play, but you should still shut down unused switch ports. It is a security best practice. Before you configure speed or duplex, give each interface a description. A simple text string that tells you what is connected. Use interface range to configure multiple interfaces at once. Interface range Gigabit Ethernet 0/1 to 3 configures 3 interfaces in one command. Run Show Interfaces description to see the full list. Now speed. An interface speed is the maximum rate it can send and receive data. Most interfaces support multiple speeds, 10, 100, and 1000 Mbps. By default, Speed Auto is enabled. The device uses auto negotiation to figure out the best speed, but you can manually configure it with speed 1000. And here is a subtle thing. Default settings like Speed Auto do not appear in the running configuration. They are hidden to avoid clutter. Duplex. This is where the real problems live. Full duplex means both directions simultaneously. Half duplex means one direction at a time. You take turns. Think of a 2-lane highway versus a single-lane road, where traffic from both directions has to wait. Before switches, we had hubs. Hubs are layer 1 devices. They are glorified wires. When a hub receives a signal on one port, it repeats it out of every other port. Every device in the LAN receives every frame. No memory, no intelligence. And if 2 devices send at the same time, the hub floods both simultaneously, creating a collision, a garbled mess of electrical signals. All devices connected to a hub share one collision domain. Only one device can transmit at a time. That means half duplex. And to manage collisions, devices use CSMA/CD, Carrier Sense Multiple Access, with collision detection. Listen before talking. If a collision happens, send a jam signal and wait a random time before trying again. Switches changed everything. Every switch port is its own collision domain. No shared medium. Collisions. Full duplex by default. Every device can send and receive simultaneously. Now, auto negotiation. When both devices use auto negotiation, they advertise their capabilities and pick the best common mode. Highest speed first, then full duplex over half. Simple. But what happens when one side is manually configured and the other uses auto negotiation? The auto-negotiating device tries to sense the speed. If that fails, it falls back to 10 megabits per second. And here is the critical rule. If the speed is 10 or 100 megabits per second, the auto-negotiating device defaults to half duplex. If the speed is 1000 megabits per second or higher, it uses full duplex. This is where duplex mismatch is born. One side is configured full duplex at 100 megabits per second. The other side is auto-negotiating. It senses the 100 megabit speed correctly, but defaults to half duplex. The link comes up. Both lights are green. But the half duplex device thinks every simultaneous transmission is a collision and sends jam signals, destroying frames. You see CRC errors, late collisions, and runts on the half-duplex side. Performance tanks. Speed mismatch is simpler. One side says 100 megabits per second. The other says 1000 megabits. The link does not come up. So both interfaces show down/down in show IP interface brief. Both lights are dark. You see the problem immediately. And here is your exam takeaway. Speed mismatch means link down, both lights dark. Duplex mismatch means link up with terrible performance. Lights green, but errors everywhere. Hubs share one collision domain. Switches isolate them. Late collisions are the smoking gun of duplex mismatch, because in a properly functioning network, collisions should only happen within the first 64 bytes of a frame.